Today in this video we will be talking about the heat and thermodynamics chapter, 8th chapter, and in the 8th chapter we will be talking 8.2.2 heat capacity and specific heat capacity. Those who have not seen the previous chapters, the link for the previous chapters will be given in the description. Kindly go through the link and you can see the videos for the previous chapters. Okay, now take equal amount of water and oil at temperature 27 degrees Celsius and heat both of them till they reach temperature 50 degrees Celsius. Note down the time taken by water and oil to reach 50 degrees Celsius. So the time taken are not the same. So water takes more time to reach 50 degrees Celsius than oil. It implies the water requires more heat energy to raise its temperature. Okay. So the time taken by water is now twice compared to the previous one. You need not check just with water. You can take one with oil, one with coconut oil, one with some other groundnut oil. So the time taken for the oil, groundnut oil or coconut oil, or for the water to reach by a boiling point or 50 or some degree of Celsius, 60 degrees Celsius or 70 degrees Celsius, definitely will differ. Okay. Now the reason for one of the reasons for this is a liquid which is more dense will heat up more quickly, whereas water which is very lighter and which is less denser than that of oil will take more time to heat and reach 50 degrees Celsius. For example, a solid will reach 50 degrees Celsius more quickly than a thicker oil. Okay, a oil which is very thick and very dense will reach 50 degrees Celsius more quickly because the heat will get transmitted through the molecules which are denser. Okay, in a thick oil there are more number of molecules, so the transmission of heat takes place very faster. Okay, so the 50 degrees Celsius or 60 degrees Celsius is reached very quickly, whereas in the case of water, molecules are not closely packed as that of a solid or that of a thick oil, so it takes more time. And it will take even more amount of time in case of air than that of water. Okay, now we will see what is a heat capacity. Heat capacity is defined as the amount of heat energy required to raise the temperature of a given body from T to T plus del T. Okay, now heat capacity formula is here. Now specific heat capacity of substance is defined as the amount of heat energy required to raise the temperature of 1 kg of substance by 1 degree Kelvin or 1 Kelvin or 1 degree Celsius. See, here it is written as heat capacity. Here it is written as specific heat capacity. So the difference is, in the case of heat capacity, they have just written as the heat energy required to raise the temperature from one temperature to the next temperature, that is the higher temperature, whereas in the case of specific heat capacity they have specifically mentioned the kg. They have specifically given the mass and the temperature by which it has to rise. So in the specific heat capacity they have specified that 1 kg of a substance has to be raised by 1 degree Celsius or 1 Kelvin. So that is why it is called as a specific heat capacity. The formula for specific heat capacity is again del Q is equal to M. Okay, M that is specific heat capacity into del T. M is the mass that is 1 kg. We are actually heating a mass of 1 kg, so that's why we take mass. Okay, now we have to find S alone. So S is equal to, we take Q on the one side and M goes down and del T is here. Okay, that is difference in the temperature. S is known as the specific capacity of the substance, and its value depends on the nature of substance, not on the amount of substance. Okay, the specific heat capacity, suppose what they are saying, the amount of heat energy required to raise the temperature of 1 kg of substance. Say for example a 1 kg of oil, 1 kg of water, 1 kg of groundnut oil, 1 kg of steel, okay, 1 kg of aluminium. So for each of these, to raise, for example, let us take an example of aluminium. Okay, let's say aluminium is there. So we have 1 kg of aluminium. Here we have 1 kg of steel. We have 1 kg of steel. Here we have 1 kg of, say, gold. So we have to this is at everything is at 28 degrees Celsius, 28 degrees Celsius at room temperature. Okay, now we have to increase each of these by 1 degree Celsius. Okay, that is our objective. So for aluminum it will take say for example 30 minutes. So for steel it may take about 40 minutes. For gold it may take about 50 minutes. So the time taken will differ. So when time taken differ, naturally what happens, the amount of heat energy consumed in order to increase it to 20, from 28 to 29, if it has to increase, the amount of heat energy required to be given also is differs. Here it has given the specific heat capacity of substance depends only on the nature of the substance, not on the amount of substance. Okay, if suppose if this is 1 kg, if this is 2 kg, if aluminum is 1 kg, steel is 2 kg and gold is 3 kg, it doesn't matter, but only it depends upon the nature of the substance. Okay, that is the nature of how densely a material is packed, etc. Okay, now the SI unit of specific heat capacity is joule kg Kelvin, kg to the power minus 1, Kelvin to the power minus 1. So see here, yes, we have kg. Okay, joule. What is the unit of heat? Joule. Now what is the unit of mass? Kg. What is the unit of temperature? Kelvin. So that's why we write it as joule by kg Kelvin. Okay. The heat capacity and specific heat capacities are always positive quantities. Remember this, all these will be 1 mark questions. The heat capacity and specific heat capacity are positive quantities because we are not talking about the temperature getting reduced. We are only talking about temperature getting increased. Okay, is raised. See here the word, remember just note down this word. We are only talking about the amount of heat energy required to rise. Okay, so here also the temperature is del T plus del T, which means the temperature is rising. So that's why it is saying the heat capacity and specific heat capacity are always positive quantities. We are not talking about negative quantities here. We are not talking about temperature getting reduced. Okay, all this will be in 1 mark question. Okay, now here they are given the specific heat capacities of various substances. See here, among this you see the amount of heat required to raise the water is very high. Okay, see here the amount of heat required for say for example copper, steel, etc. is very less because the copper and iron, etc. are the molecules are very densely packed. So the heat, when we heat some steel or when we heat some copper, okay, we have a copper here, and when we heat it here, since the molecules are very closely packed, the heat gets transmitted very fast. So we don't need more amount of heat energy to rise from, say for example 28 degrees Celsius to 29 degrees Celsius or 30 degrees Celsius. Okay, whereas in case of water, okay, we have a container, we have a water, and when we have to raise it same from 28 to 30 degrees Celsius, more amount of heat energy is required because the molecules are very widely distributed, not closely or densely packed as like that of iron or steel. That's why we need more amount of energy or more amount of heat energy. Okay, as it is given in the body, as it is given in this table. From the table it is clear that the water has the highest value of specific heat capacity. Remember this. So they will give few choices in the examination, and they will ask which of these has the highest specific heat capacity. So among this, see, remember these things. So you can compare. Apart from water, they may also give other materials, and they may ask you to give the specific heat capacity and give the choices. It is used as for this reason it is used as a coolant in power stations. So the question will be asked as, why water is used as a coolant in power stations and power reactors? Why? So they will ask the question, why water is used as a coolant in power reactors? Why? So you have to write it. Water is used as a coolant in power reactors because it has the highest value of specific heat capacity. You have to use this technical term, the specific heat capacity. Okay, that is the answer for that. Now we will see When we study properties of gases, it is more practical to use molar specific heat capacity. Okay, so normally for materials and liquids and hard materials, we use specific heat capacity. Now, when we are talking about gases like oxygen, argon, neon, etc., we use molar specific heat capacity. Okay, when we are studying the properties of, when you see the word molar specific heat capacity, which means they are talking about some gases. Okay, molar specific heat capacity is defined as the heat energy required to increase the temperature of 1 mole of a substance by 1 degree Kelvin. Okay, we have some container here. It is filled with, say for example, oxygen. Okay, it is a gas, so we have to increase the temperature. Say this is at 28 degrees Celsius. So we wanted to increase it to 29 degrees Celsius, okay, by 1 degree Celsius. So what is the amount of heat energy required to be given to this container to increase from 28 to 29 degrees Celsius? That is called as the molar specific heat capacity. Mu, this word is called as, this word is spelled as mu, mu. Okay, mu is the number of moles in the substance. What is the SI unit of molar specific heat capacity? Is joule divided by mole per Kelvin. So here what is the thing we used here? Joule divided by mass. So since we had some steel has some mass, 1 kg, 2 kg, etc., we used the unit as kg and Kelvin. Here, since we don't measure the gases in terms of kg, we use mole. Okay, we measure gases in terms of mole. Okay, so here it is joule. Okay, here it is joule. So for Q it is joule, for mu it is, instead of kg we are using mole. For temperature we are taking Kelvin. This is also a positive quantity. Remember this point, this is also a positive quantity. So specific heat capacity, heat capacity and molar specific heat capacity are all positive quantities. We are not talking about negative quantities. Why it is positive quantities? We are only talking about increasing the temperature. See here also we are increasing the temperature of 1 mole of a substance. We are not talking about decreasing the temperature. So it's a positive quantity. Okay friends, I hope you must have understood this topic, specific heat capacity and molar specific heat capacity. If you have any doubts, I will be happy to clarify your doubts in the please give it in the comment section. Thank you friends. Kindly don't forget to subscribe and share friends. Thank you. We will see in the next video 8.2.3 thermal expansion of solids, liquids and gases. Okay friends, bye.